Hey, what is up guys? Today we're going to be making a coin battery. Right now what I am doing is sorting all the materials I'm going to need. I have the paper towels in the top right hand corner and aluminum foil on the bottom right hand corner. I'm going to split the pennies into two groups, pennies post 1982 and prior to 1982. As you can see, the pennies post 1982 are made out of zinc coated with copper, while the pennies made before 1982 are made up of mostly copper. What we're going to do is compare the voltages created from pennies prior to 1982 and pennies post 1982. We're going to dip the paper towel into a vinegar and salt solution that will act as our electrolyte, and we will use a multimeter to measure the voltage of the voltaic cell. What I found was that voltaic cells made with paper towels are not the greatest, which is why I'll be using cardboard instead. We'll start off with pennies made after 1982. We'll put the cardboard, which is soaked in vinegar and salt solution, on top of the penny. Then we'll add the aluminum foil on top. The aluminum foil will act as our anode. Now let's measure the voltage of the first cell. This voltaic cell gives me around 0.660 volts. We will use another penny made after 1982 and place it on top of the aluminum foil. This way the anode of one voltaic cell will be connected to the cathode of another voltaic cell. We will cut out the cardboard, dip it into the vinegar solution, add it on top of the penny, and then we will add the aluminum foil on top of the penny. Next we'll measure the voltage. This voltaic cell gives me around 1.360 volts. Then we will place another penny on top of the aluminum foil. We'll cut out another piece of cardboard, dip it into the vinegar solution, and put it on top of the penny. Then we'll add aluminum foil on top. This voltaic cell exceeds 2 volts, so we will need to change the setting of the multimeter. This voltaic cell gives me around 1.9 volts. Again, we will be placing the penny on top of the aluminum foil. Then we will cut out the cardboard, dip it into the vinegar solution, and add it on top of the penny. Then we'll add the aluminum foil on top. This voltaic cell gives me around 2.3 volts. I'll cut the cardboard out, add the penny, and then add the cardboard, and then add the aluminum foil. This voltaic cell gives me around 2.9 volts. Again, we'll add the penny, soak the cardboard into vinegar, place it on top of the stack, and then add the aluminum foil. This voltaic cell gives me around 3.9 volts. Next, we'll be making a voltaic cell out of pennies made before 1982. First, we'll cut out the cardboard, dip it into the vinegar solution, and add the cardboard and the aluminum foil on top. This gives me around 0.7 volts. We'll cut out the cardboard again, dip it into the salt and vinegar solution, and add the cardboard and aluminum foil on top. This voltaic cell gives me around 1.4 volts. We're going to be doing the same thing we've been doing all video long. We'll cut out the cardboard, stack the materials on top, and measure the voltage. So it looks like this voltaic cell exceeds 2 volts. I'm going to switch it up. This voltaic cell gives me around 2.0 volts. We will repeat the process for the 10th time. Add the penny, then the cardboard, then the aluminum. This voltaic cell gives me around 2.7 volts. Again, we will add the penny, then the cardboard, then the aluminum. This voltaic cell gives us around 3.4 volts. This is the last one. We will add the penny, then the cardboard, and then the aluminum. This voltaic cell gives me around 4.1 volts. So, the voltaic cell made out of pennies post 1982 gave us 3.9 volts, while the voltaic cell made out of pennies pre-1982 gave us 4.1 volts. This is our basic battery. It has the anode, which is the aluminum foil, the cathode, which is the penny, and the electrolyte, which is the cardboard soaked in the vinegar and salt solution. So, why do we choose to use vinegar as our electrolytic solution? Well, vinegar contains acetic acid, which dissociates into acetate and hydrogen ions. Acetic acid has a low acid dissociation constant, which means it is a weak acid. In a battery, oxidation-reduction reactions are occurring. The aluminum metal is being oxidized while the hydrogen ions are being reduced. We also dip the cardboard in a solution that contains vinegar and sodium chloride because the sodium chloride allows the cardboard to act as a salt bridge, which allows both components of the voltaic cell to remain electrically neutral. In a salt bridge, the chloride anions will migrate towards the anode because aluminum is losing electrons. Since hydrogen ions are being reduced into hydrogen gas, the sodium cations will maintain the positive charge. Alessandro Volta had thought that the reduction half reaction occurred at the copper electrode, but in fact, it is the hydrogen ions that are being reduced. Thank you for watching this video. Mr. Panaro, we will miss you. Thank you guys for a spectacular school year. See you guys later.